Bangalore TV quiz show. Everybody happy? Yeah. You ready? Yeah. First question. What is the title of the article published by Thomas Bayes posthumously? Well?
Next.
Pass.
1 point? 2 points?
No, 1 point.
1 point.
No.
The answer is Essay Towards Solving a Problem in the Doctrine of Chances. You were very close. Congratulations. All right. Next question.
Number 2.
Ready? How many years after his death did this article appear?
Please don't say.
Number 2. 10.
10?
3 years.
2 years.
Oh, sorry, 3 years. Can't jump like that. When you have team
You
1,
don't
team
get
2.
the answer, they should say pass.
Okay.
Say pass, you can't answer. Okay?
Well, the answer 2,
We have not yet answered.
the answer 2 is correct. Congratulations.
Team number 1?
The answer 2, is it? Yeah.
Team number 6 gets 1 point.
Team number 6.
Next question to team number 3.
Team number 3, are you ready?
Yeah.
In which journal was this article published?
Biometric.
What?
No. This is biometric.
Biometric? No.
Number 4. Number 5.
I can't hear you. Speak up.
Journal for the Society of Philosophical Proceedings.
You're the judge.
You're the quiz master.
Well, I think we can give them 2 points. 1 point? 1 point. The title of the journal is Philosophical Transactions of the Royal Society of London. That's a hard one. Let's take a picture.
Let's take a picture.
We'll relax a little bit. Now, who is this?
Team number 4. Team number 5.
Laplace.
One only.
No, you cannot.
Team number 5 is correct.
Yeah, that
Correct.
is correct.
Remarkable. Congratulations. Okay.
Next question to team number 5.
You ready? Who sent Bayes' paper to the Royal Society?
Seven. Laplace.
No.
8. Bayes' son.
His grandmother.
Jeffrey. Four. Audience.
Yeah.
The answer is
Richard Price.
Richard Price.
Where's the chocolate?
Chocolate.
Oh, chocolate.
Chocolate is there. We'll give it to you afterwards. No, it's there? Yes? Okay. Okay. Chiranjeev, yeah. Wow, that's great.
Ah,
Oh, throw it. And you
give her 2 points. Put her on the baseball team.
Team 6.
Okay. How many other works did Thomas Bayes publish?
2.
Perfect.
Yes. 2 points.
Perfect.
Excellent.
2. She got it right. Whom did Bayes defend in an introduction to the doctrine of fluxions and a defense of the mathematicians against the objections of the author or the analyst? Whom did he defend? No.
Pass. 1, 2, no. 3, 4, 5.
Oh, this is a very hard question.
Audience.
Sir. Whom did Bayes defend in his An Introduction to the Doctrine of Fluxions and a Defense of the Mathematicians against the objections of the author or the analyst? Sir Isaac Newton. No,
Chocolate for the quiz master.
I think he's a cricket player, Sir Isaac Newton. He played for the Indian team a few years ago. Well, what was this all about? This paper. What were they arguing about?
It's about God. P1.
Astronomy.
What?
Astronomy. Problem of astronomy.
No. Next.
3, 4,
These are hard questions.
5, 6,
On point.
Points, continuity and points.
No.
7,
The earth is sphere or not?
That's the logical foundations of the calculus. Bayes was deeply involved in the foundations of the calculus. Okay, I'm going to skip a question, okay? Who used Bayes' theorem to estimate the probability that the sun will also rise tomorrow? Who used Bayes' theorem to estimate the probability that, quote, the sun will also rise tomorrow, unquote? Harold Jeffreys? No. Close. You're very close. No. I had nothing to do with it. Get my lawyer. I'll get my lawyer.
4,
No.
5,
Laplace. Great. I think we got some professionals over there.
Team 2 gets the next question.
Let's give ladies the credit.
Team 2. Who gave Bayes' rule its name? Who named Bayes' rule? Bayes' rule.
Carl Pearson.
No.
3,
Jeffrey.
No.
4,
I can't hear you. No. Not Wolfgang Polasek.
Mitchell.
7,
Rice.
No.
Laplace.
No.
Laplace for the board bucket.
Stigler? No. No.
2,
Definitely? No.
Newton.
Newton? No.
Audience.
Poincaré. Okay. I think we need another picture. Break. Picture.
Answer from the quiz master.
Yes.
No.
You were right. All right, another picture.
Point here.
83,
Well, that's hard to see.
Team 3,
One only.
No.
4, what is the Who is
I
that?
think it's a Bayesian.
5,
Jeffrey.
No.
6,
Fisher.
7, Team Root.
No.
Yvonne Pearson.
No.
1,
Definitely. Yes.
Definetti.
No,
Not allowed.
This was Definetti as a young man.
First one question.
Team 4 gets the next question.
The next question is, we'll probably throw in a question about a frequentist. Who was the first person to challenge Bayes' conclusion? Which referee? No. Who was the first person? This is a hard question, really. I'm going to ask them to throw some questions at you.
I have to give them the reference.
Pearson.
No,
5,
Neiman.
no.
7, 8. George Boole.
Yes.
Very good. Very good. Now, in what book did this criticism appear? By Boole. What book?
Which did?
D5.
Missed the question.
In which book did Boole start objecting to his conclusions? What is the name of the book?
Six, 7.
Boolean algebra.
They should be given.
Thought.
He should be given a job.
On laws of thought.
That's right. Beautiful. Okay, what kind of prior did Laplace use for solving all the statistical problems he addressed?
Team 6. Uniform distribution.
Uniform, right?
Yes.
Congratulations. Beautiful. Okay,
Team 7.
Team 7. Which two great economists are also famous Bayesians?
I know.
That's an easy one.
I mentioned it this morning. Were you listening?
Were you listening this morning? Yes.
Edgeworth and Professor Zellner.
No.
Only 1 point.
I exclude myself. Who was the other economist?
Friedman.
Right.
Yes.
Beautiful, beautiful.
Okay, you do.
Okay, the next question,
Team 8.
Team 8. Oh, this is a hard question. What is the relationship between Jeffrey's prior and the Fisher information in the single parameter setup?
Both same.
Exactly. He's a professional. Okay, this one is very important. In which book did Jeffreys propound his Bayesian viewpoint and results?
Theory of probability.
Right, beautiful. In which year did this book first appear?
Team 2.
1971.
Jeffrey's book. Jeffrey's book.
Team 3. 64. 61.
What?
5.
5?
69.
6.
70.
7.
1961.
8.
No.
1960.
No.
1959.
57. No.
1939.
He is the closest.
You're right. 1939 is the correct answer. He
Little
got
chocolate.
it. Congratulations.
Team 2. Team 2 started with the questions.
So you get a chocolate.
I don't know. Yes.
Give him 70%.
They don't get a point. They don't get a point, but they get a chocolate.
Yes, yes.
Okay. He's happy.
Team 3.
While Jeffreys was a physicist, who were the contemporary economists famous for their theories of subjective probability?
Team 3.
Please will you repeat?
While Jeffreys was a physicist, who were the contemporary economists, contemporary with Jeffreys, who were famous for their theories of subjective probability? Economists, actuaries, etc.
4.
We are doing chances.
5. 6.
D group.
7. 8. Keynes.
Keynes? He wasn't a, he's not a Bayesian.
Thiel and Morgenstern.
No.
2.
Carl Pearson.
Anybody in the audience?
Well, the answer is Bruno Di Finetti, Frank Edgeworth, I'm sorry, Francis Edgeworth, and Frank Ramsey. Okay,
Team 4.
here comes a mathematical question for you. What mathematical conclusion of Di Finetti's theory most profoundly separates subjective probability from that of Kolmogorov's probability? What mathematical assumption differentiates the two?
No large numbers.
No,
5,
right in your area.
6,
Independent distribution.
7, 8.
Only a finite number of outcomes.
Well, he's close enough. Finite additivity. Okay, the next question.
E5.
What is the fundamental difference between the Bayesian view of probability and that of the frequentists?
It's not uniform probability because you are imposing what your knowledge is on the prior. You form your prior with your knowledge. So that is the.
No, well, that's right, but it's not. It's the right answer to the wrong question.
For the frequentist, probability is the limiting value of relative frequency for a large number of experiments. While for the Bayesians, it's the combination of prior knowledge and.
It's what?
While for the Bayesians, it's not like that.
It's not a limiting frequency. What is it? You got to tell me what it
For the
is.
frequentist, it is the limiting value
Limiting
of the.
frequency.
For the frequentist, it's the limit of limiting value of the number of times that an event occurs in a large number of experiments.
Okay, now what is Bayesian? Give her half.
You would have 1 point.
Okay.
No. So maybe you should explain the other half. You
No.
you ask us. Let the round be complete. You get the other half.
Well, the probability of A given B is interpreted as the degree of confidence in the occurrence or truth of the statement or event A when one has information on the occurrence of B. So for Bayesians, probability is a measure of degree of confidence in a proposition. And you're right, the frequentist long-run frequency point of view. Look at Jeffrey's book, Theory of Probability, Chapter 7. And you'll see a beautiful discussion of different concepts of probability. Photo. He's going to have Surekha Rao's photo up there.
Team 6.
1 minute, hold on.
We get the question.
Team 6.
Who is that? It's a terrible picture.
That's the best we can get.
Very young.
Very young. Well,
7.
who? No, that's not. No.
Mr. Zellner.
No. I never wear a bow tie. Who?
Friedman.
No.
3.
4, 5,
Well, this one is hard.
There's a Prem Goel.
Prem Goel.
In the back? I think he's right. Give him a chocolate bar. Savage. He's a real Bayesian, out of Delhi. This is a very early picture of Savage. Very difficult, very difficult. Okay, now we've got to get back to work again. So, which asymptotic result or law is the heart of Monte Carlo methods of numerical integration?
Law of
Which?
large numbers.
Oh, good.
Great! Congratulations, great.
Team 8.
Okay, what is the relationship between maximum likelihood estimation, Fisher information matrix, and the posterior distribution in a regular case? How do you link these things up in a regular case? Team 8.
Fisher information is equal to maximum likelihood multiplied by the posterior.
Well, I guess part of it, but in
Part of it.
in large samples, what happens? I'll give you a hint. In large samples, what happens to the posterior distribution under regularity conditions? In general,
How much?
1 part. What's the mean?
Mean is the Fisher information matrix.
No, the mean of the parameter vector. What is the relationship between maximum likelihood estimate, Fisher information matrix, and posterior distribution in large samples?
Determinant of the Fisher information raised to the power of.
What is that? That's the mean? No, that.
Mean is the maximum likelihood estimate.
There he is. And the other?
Is the minus 1 over Fisher information.
Okay, that's close enough. Okay, right. Who first advocated the use of entropy in formulating prior distributions? Who first advocated the use of entropy in formulating prior distributions?
Shannon.
D group.
No?
4, 5, 6,
Zellner?
Yes.
No, I wasn't born. No, I'm joking.
8, Burger,
No.
audience.
James,
Right, exactly.
what are you going to do with so many chocolates?
Another chocolate bar.
Share with us.
You get a stone cake.
Edwin T. James is a well-known physicist from Washington University, and the early person who suggested using the entropy approach in a variety of contexts, including producing priors.
Team 2.
What? Why? How do you justify the statement that Bayes' theorem is 100% efficient from an information theoretic viewpoint? That statement appears in Bernardo and Smith's work and so forth. Bayes' theorem is 100% efficient.
Team 2.
Could you say it a little loud? That sounds wrong, is there?
Team 3. 4. Question again.
He wants the question.
Oh, yeah. How do you justify the statement that Bayes' theorem is 100% from an information efficient, from an information theoretic point of view?
You do various analysis of various outcomes for the, and you get the total function as a breakup of two, one as prior and one as.
That was hard to hear. Did you hear that? Wrong? Okay, we go on to the next one.
It uses all possible information and incorporates that in the model, just like the rational expectations. So it is 100% efficient in that way. It just incorporates all the available information
No.
into the model, forming expectations.
No, it isn't proved that way. No. Maybe you should introduce rational expectation, but that wasn't done here.
Bayes estimators are efficient in small sample cases.
No. Next.
7, 8, pass. 1,
Pass.
Correct, that's why that was.
audience.
Well, if you measure the output information minus the input information in the prior and the likelihood function, and you vary that difference with respect to the output density, the posterior, subject to the output density being proper, the solution is Bayes' theorem. Take the output density according to the Bayes rule, and when you do that, the information out equals the information in. You haven't lost any. So that's 100% efficient. Okay, I'll skip the next. No. All right, who proved this result?
Team 3.
He put this question and I didn't. That'll give you a hint.
Can you?
Jeffries? No.
No D group.
Who? The group? No.
Savage.
No.
Zellner?
Yes.
He put the question and I didn't. I gave him a hint. Oh, well. Okay, here's a hard one. Who caused a fire in a chemistry lab and subsequently switched to mass.
Savage.
Right. No, they're up. Very good. Okay, what articles in the economic literature brought together economic utility theory and statistics?
Please, you.
What?
Not team one.
What articles in the economic literature brought together economic utility theory and statistics?
Six. 7. 8.
Treatment and savage.
Exactly. Beautiful. He was listening this morning. Okay, let's have another picture.
Before that, could you please the team scores? Where to the stand?
You'll have to work harder. Side payment. No. Okay.
Team 6.
Okay.
There's a picture now. Who is that?
Team 6.
Laplace?
7. Newton. 8. Here the formula.
Bernoulli.
1. Yes.
Who said Bernoulli? Hey, good.
Yes.
Good. Excellent. They were listening to Wolfgang Polasek. What is a fundamental contribution of Savage in his book, Foundations of Statistics? What is one of the fundamental contributions there?
Link between utility theory and statistics.
Exactly. Beautiful.
So it was already a question which was posed, so perhaps this question should not be asked. This was a question which was posed to us in the reverse. Since that question was answered, this is automatically answered. So
Seven may be having
perhaps
lots of
another
contributions.
question.
7 may be having lots of contributions.
All right. In which year was that? What? Team 8. You ready? You sure? In what year was Savage's Foundations of Statistics published? What?
1970.
No.
1960.
No.
1957.
No.
45.
No.
54.
You say 54?
Yeah.
You're right.
Team 1 gets next question.
All right. What is the Jeffreys prior for mu and sigma in a normal mean problem, where x is normal with mean mu and variance sigma squared? What is the Jeffreys prior for that problem? The Jeffreys prior for that problem. The Jeffreys prior for mu and sigma. No.
1 by sigma square.
Right.
Yay.
He revised the procedure. Now this is controversial. I think we should give 1 point here. Well, because it does use 1 over sigma. So the question is ambiguous.
Just look at team 1 splitting the jet body. Great.
Okay. Next question. What is the form of the natural conjugate prior for mu and sigma in the location parameter location problem?
Normal distribution with gamma mean.
Normal gamma?
Yeah.
Yes.
Right. Great. Give an example of a proper prior yielded by Jeffreys' rule.
Team 3.
For what problem
Normal
does...
sigma square.
What? For what problem does Jeffreys' procedure, the determinant of the information matrix to the 1/2 power, yield a proper prior? Okay.
Any other question?
Maximum data information prior.
No, that's all wrong. Jeffreys' method. 7.
Now, when is Jeffrey's prior proper? Give example of a situation where Jeffrey's prior is proper.
Log normal distribution.
What?
Dirichlet distribution?
Inverted comma?
Multivariate.
No, he gave correct answer. It's a Dirichlet. Dirichlet.
Right, that's a,
Yes.
that's a special case study.
Thank you.
No?
Well, Dirichlet distribution.
Well, it's also proper for the binomial and the stationary AR1, among others. Okay. Which other reference prior for the binomial parameter is proper for this problem? What other procedure yields a proper prior for the binomial parameter?
A.
No, procedure.
Name of the procedure?
The what?
Each other prior.
Which are the prior?
That
A proper prior for the binomial parameter. What other procedure yields it? There's several answers to this question. No, next.
Beta?
No. What procedure for producing priors yields a proper prior for the binomial?
maximum data information prior.
Maximum what?
Maximum data information prior.
Right, that's right. And the maximum entropy prior for this problem is uniform and proper. So maximum entropy or maximum information prior. All right, I'm skipping some of the questions because they're too hard. What is a Bayes factor? What is a Bayes factor?
Comparing the prior and posterior distributions.
What? I can't hear you. Speak up.
While doing testing of hypothesis, the Bayes factor is the probability of the data given a hypothesis divided by probability of the data given the other hypothesis.
Right. Right. Okay, not complete, but close enough. Okay.
Probability of hypothesis.
Well, it's the ratio of the posterior odds to the prior odds. It's also the marginal data, the density of the data evaluated at the sample under one hypothesis. So she got it right. Yeah. Okay, for what kind of loss function is the Bayes estimate the same as a posterior quantile? Okay.
It's absolute error loss.
No. Next?
Quadratic loss.
No.
Square error loss.
Please repeat.
For what kind of loss function is the Bayes estimate, the optimal estimate, the Bayes estimate, the same as
0 K loss.
no? What?
9x.
No.
0, 1?
No. In the back? What?
Absolute error.
No,
That gives
that
one
is
particular point.
Modulus.
In general,
That's the term I'm using.
half a chocolate.
Convex linear loss. Is that what you said?
Modulus of synchronization.
It's hard to hear you here.
Absolute error.
That's a special case.
Convex linear loss. Right.
7.
Under what loss function is the Bayes estimate equal to the posterior mean?
I know.
Increase it directly.
7.
7. Oh my God, no.
Square error loss.
Square error loss, right?
Yes.
Right.
He made.
All right. Give an example when the p-value coincides with the posterior probability of the hypothesis. Remember Fisher's p-value? When does it coincide with the probability
Of alternative H is this.
of what? I can
H of alternative hypothesis.
of the alternative. Okay, of the alternative hypothesis. It's amazing that the p-value is equal to any probability on a hypothesis. But what is an example? Okay, next. That was the answer.
Binomial.
Binomial, no. Okay. Okay, the answer is a one-sided hypothesis testing for the normal mean with known variance and a uniform prior. Give an example in the multi-parameter situation when the Berger-Bernardo prior coincides with that of Jeffrey's procedure, or coincides with the Jeffrey's prior.
Example.
What model? What problem? Okay, well.
2, 3, 4. Normal mu sigma matrix. The sigma matrix is sigma square. 5, 6.
Okay, well.
8.
Pass.
You pass. he's playing poker. He's a poker player. Okay, this is in the case of, remember, stationary AR1 process. We discussed that in one of the meetings, I think. Okay, the last question. Oh, picture. Picture.
Friedman.
Who?
Pass.
4. Jeffrey.
Right. That's great. That's Sir Harold Jeffreys. Right. Okay, now the last question, and I think you should all get this one very easily. Name the most famous Bayesian student of Professor C.R. Rao.
4.
No.
5. 6.
S.B. Rao.
The hard question.
Yes.
Pasu, yeah.
He didn't come to it.
Beautiful. You pass on this question?
He didn't come to it.
You already.
Well, thank you for your participation. And if you have any hard questions, ask Professor Rao or Professor Talabadi.
Years again.
Thank you so much.
Our pleasure.
Let me welcome you with a bouquet of flowers from the garden of Indian Statistical Institute at Calcutta. Let us go in retrospect some things that I will come back to the ones and some suggestions regarding this workshop and future workshops and so on. As you know that the Indian Statistical Institute was founded by the great visionary Professor P.C. Mahalanobis in 1931. There were just 3 people at that time of different disciplines who gathered on 17th December 1931. One is a mathematician, one is an economist, and Professor Mahalanobis had background in physics. And at the same time, the Journal of Sankhya was conceived, and though it started publishing in 1933. As you know that the logo of the institute is unity in diversity, the one which Professor Zellner was saying in the morning, statistical science and its impact on various disciplines. As you know that the Indian Statistical Institute made seminal contributions in several areas. I listed only a few of them. These are sample surveys, design of experiments, which are very much useful in agricultural experiments as well as industry. And the philosophy was theory and practice should go hand in hand. You have to apply the things to the development of the nation and the world in particular. The word statistics, a key technology, has been given by Sir R.A. Fisher, who supported the institute in the initial stages. The Indian Statistical Institute contributed immensely to the development and the planning of the country, especially the National Sample Survey Organization and Central Statistical Organization were conceived at the Indian Statistical Institute. And because of the recommendations of Professor Mahalanobis and his distinguished scientists at that time, these were made possible in the government with the support of the late Prime Minister Pandit Jawaharlal Nehru. And I have listed some names of people who have contributed immensely to the development of statistics from India and from the Indian Statistical Institute. And one old photograph will tell us, this really old one. You can see Sir Fisher here, Pandit Jawaharlal Nehru, the Prime Minister, and P.C. Mahalanobis. It's lost in Short is supposed to be there, we'll come back. And this is the objects of the institute. At that time, to promote the study and dissemination of knowledge of statistics, to develop statistical theory and methods, their use in the research and practical applications, generally with special reference to problems of planning of national development and social welfare. To undertake research in various fields of natural and social sciences with a view to the mutual benefit of statistics and these sciences. To provide for undertaking the collection of information, investigations, projects, and operational research for purposes of planning and the improvement of efficiency of management and production. In the beginning of today's lecture, I was fortunate enough to hear Professor Arnold, who said that statistical science has interfaces. SS stands for statistical science, has interface with industry. Statistical science has interface with planning and governmental efforts for national development. Statistical science is an interdisciplinary subject, and it can extract truth from the data. Of course, that data will reveal to only their admirers. So we have to admire the data enough to get the results or use appropriate technologies to get the conclusions. It's multidisciplinary also. And now statistical science has impact on the computer science and vice versa. The computer science techniques can be used to analyze the data to get the results. And of course, there is a boom in information technology and statistical packages and other packages which we may have to use. I would like to add what Professor Polasek said in the morning out of Africa theory. In the Indian Statistical Institute, just a few months back, there was an analysis of the data of actually various ethnic groups of India through what is called, the main thing is mitochondrial DNA markers. It is known that this is from mother to, it comes only from mother to the offspring, not from father. So using this and the data, it was shown that there is a prehistoric demographic human expansions in India and migrations of humans from India to Southeast Asia. This is done by the Department of Biotechnology, Indian Statistical Institute, Institute of Chemical Biology, and Saha Institute of Nuclear Physics. And this got an award called Millennium Award, and it was awarded in the last Indian Science Congress. This was done by Professor P. Partha Majumdar and his colleagues from the Indian Statistical Institute. I would like to add that Professor Mahalanobis used to say against brain drain, used to call brain irrigation. So you invite people of great caliber, eminent scientists in several disciplines, and invite a group of people who are interested in the subject and irrigate their brains for green pastures. So that was the philosophy of Professor Mahalanobis, who of course invited eminent people like Fisher, Yates, Wiener, Kolmogorov, Wall, Jabez Haldane, Kunz, and you can see many economists also. In fact, I would like to say that second 5-year plan of the Indian national planning was done by Professor Mahalanobis and this. And I hope that with the several experts who came here, the brains will be irrigated further for all of us. Yes. And of course, Professor C.R. Rao, who contributed extensively to the development of the institute through his researches in several areas of statistics and applications. And of course, this is an early photograph of whose photograph is this? Professor C.R. Rao.
In the middle, the highlight.
No. Wiener. Yes. It's very difficult to see Professor C.R. Rao and Professor Kalyanpur, of course. Now, there is no marks for this. Who is this one? Professor C.R. Rao. And you can see great experts, Walter Schubert, who was responsible for the development of the quality movement in India. He came here for several years in 1947-48, and he was responsible for the development of the quality movement in India and exclusive war techniques. As you know that just now Professor K Ghosh was mentioning that the idea of design experiment and Taguchi methods, the design of experiments and the orthogonal arrays were actually invented here by Professor C.R. Rao, Professor R.C. Bose and so on, but for some reasons the Indian government has not used them in spite of possibilities of that. But Professor Taguchi explained it to the managers in their language. That's very important for practice of statistics. You have to explain these things in the language of the user and then use it for the excellence of Japan. And of course, of late the Indian government also realized this, and they made what is called a Quality Council of India, in which of course rightly the Indian Statistical Institute is a permanent member. I would like to just say, please answer, who is this? The answer is, I have put it in intentionally as you all said. Haldane, Professor Haldane, Professor P.C. Mahalanobis and Niels Bohr, famous physicist. The Indian Statistical Institute originally used to be in a small building in Presidency College in Calcutta, but it moved into the new campus, and that's the first building we had. And you can see the shape of this building. This is like a histogram. And of course, there are some colors added to this with the environment and so on. Yes. And that's the building. I invite all of you to visit Indian Statistical Institute headquarters at Calcutta. And of course, we have two centers now. One is Delhi, the other is Bangalore, big centers. And also we have branches at several places like Chennai, Hyderabad, Bombay, Baroda, Pune, Coimbatore, and also we have an experimental farm at Giridih where the jute crop experiments were conducted, and the estimation of the crops in India, jute surveys were made, and the estimate of crops in India were made based on that still now by the Indian government with some modification of experimentation. And that's a famous building where Professor Mahalanobis used to stay. This is called Amrapali, the name given by the Gurudev Rabindranath Tagore, who said that we should live in harmony with nature. And the environment plays a dominant role now in the world now. So that is another important aspect. Statistics and environment is another one. Of course, I will stop here with one more slide on these people and the one. Now, these are the people, Taguchi, Professor Deming, and Professor C.R. Rao, Professor Tippett. These are experts of, among others, the quality movement also. We had 50 years of experience of quality movement in India, and we have trained so many people in the industry, and we can see the methods, application of design of experiments and Taguchi methods and so on. The Taguchi methods now, as Professor K Ghosh says, some of these design of experiment methods have to be modified. There is another one called Mahalanobis D square, which is famous, which is useful in many things, and there is a initiative being taken to use that for the quality development also in the industries. And this is a famous collection of glimpses of Indian statistical heritage. I would like to put these next few slides, especially because Professor Zellner was there at that time. The Delhi Center was inaugurated again by the then Prime Minister, Professor Rao, Mr. P.N. Axer, who was the chairman of the Indian Statistical Institute for several years and who passed away unfortunately recently. And that's the campus at the Indian Statistical Institute, Delhi. I would like to say that there was a conference held at the time of December 1974 in economics also, and Professor Zellner perhaps was there at that time, but I'm not sure whether he's there in this photograph. I think Sukumai Chakraborty or some more people are there. And I will have another photograph of that, but I don't know, he's not there either. And quiz question, what is this one? Yes, we used to compute, using this kind of techniques, all facet machines and so on, but the things have changed. Now there are new things, optimal communication, high-speed VLSI technology, new software paradigms will make a remarkable change. In few years, all the PCs will disappear. Why? Because the PCs will be small in size, maybe around a belt, around the headgear, or maybe wristwatches and so on. There will be the future PCs in about 20 years. In that sense, the distance concept will reduce. The virtual reality, you can talk to people directly through all these communications with, as if you are there and so on. And we have to adopt these techniques and the packages for the improvement of. So there are several such things, and of course we have to see that the education effectively is also made accordingly. I just want to give some data, being from Indian Statistical Institute. What is happening is that if you look at the people who are above 65 years age and between 0 and 14, the percentage now in Japan just is around 16%, but this is 21.5. But whereas this is like this. So after some years, the Japanese population over 65 will be more than the people who are in the group of 0 to 14. Whereas in some other countries like China, Brazil and India, it will be the other way. So what we have to do is, we have to, let me say the world grows grey, but India is getting younger. So there are lots of human resources which can be developed if that is properly used by the government, including the IT potential. As you know, Silicon Valley. Why Silicon Valley? Why not Indus Valley? After some time, the Silicon Valley, many things are contributed by the Indians. So why can't the government take efforts to see such a thing is there in India also? Of course, there is some such possibility being done now. The Indian Statistical Institute is also famous for excavating dinosaurs. And I would like to say that it's not just a coincidence. They had some data. It is called directional data, using which they could spot that such a dinosaur possibility is there. And the directional data analysis is a new statistical methodology which is being used now in medical imaging and many more. So it's a great pleasure to be here today and to hear the lectures also. And I would like to mention that without the active support of the experts, both financially as well as being present here and giving extensive lectures, discussions with the participants, this would not have been a success. And credit also should go to the organizer, Professor Surekha Rao. So I thank all these people who are here, and also the active interest of all the participants which made it possible. And I would like to say that the Indian Statistical Institute should see that this continues as a sequel, not just as a workshop, but as an international conference. I seek the support of the experts here and who came here and discussed these things here to be with us at the international conference which we are planning in next couple of years. That's the first thing. Second thing is that the Indian Statistical Institute with experts at Calcutta, Delhi and Bangalore and people around should have a center for the Bayesian analysis and its application so that you can get more money from the government. Also, as you know that these can be applied. We are fortunate that the Governor of Reserve Bank is the Chairman of the Council of the Indian Statistical Institute. So if you can rightly use these in the forecasting of several financial things, there is no dearth of money. And I seek the collaboration, participation of both the seniors and the youngsters in this venture. And it is also necessary perhaps to have a journal in this area from Indian Statistical Institute or sponsored by appropriate bodies. And I hope the fourth point I want to mention is that the education system should be geared that such a things should be introduced as formal courses in the universities soon, and we should make efforts to see that these are done. And I thank you all for giving me this opportunity. It's a great pleasure to meet so many seniors and also young and active researchers around. And I wish you all happy New Year again. And let's hope that it will be a green century and green millennium for us. And the Indian Statistical Institute, with your collaboration, will have a dynamic role to play in the development of this branch and in the national development in this century. Thank you very much.